So good afternoon and welcome. My name is David Rubel. I'm a Senior Business Development Manager here at AWS, and I'm responsible for the AWS Snow family and the Worldwide Public Sector Organization. It's really my honor today to share the stage and co-present with Quinten Donlon with Hypergiant. If any of you sat in the keynote this morning, you saw a very, very interesting presentation from Quinten relative to how Hypergiant is leveraging Snow services to be able to solve and provide some very unique capabilities and really focus on evolving that edge from that perspective. So today's breakout is focused on those set of edge use cases that are related to providing analytics at the edge. And we're going to talk about this today in two sections. First, I'm going to kind of kick it off in terms of if anyone is either aware of or has background with the AWS Snow family. We'll kind of start there top down, and then I'll hand it over to Quinten and really talk much further about the use case in terms of how Hypergiant is leveraging the Snow family and the Snowball Edge device in their particular mission requirements. So again, Quinten Donlon is the president of Defense and Space at Hypergiant, and it's really an honor and a pleasure to be able to share the stage with you today in this discussion. So as I said, here's the formal agenda for today. So I'm going to start to set the stage in terms of what we mean by edge and edge to cloud. There's a lot of terms here that you hear regularly if you see it out in social media or you attend shows. So we'll kind of baseline that a little bit. We'll talk about the AWS Snow family. If you are familiar, that's great. If you're not, we'll spend some time just kind of some of the basic facts there. And then, like I said, I'll hand it over to Quinten for that deeper discussion about the Hypergiant capabilities built on the Snowball Edge. So the discussion about edge computing is really interesting. When you go to trade shows these days, there's themes. Most recently, say over the last year, maybe year and a half, edge and edge computing has risen to the top. And it's not unusual, if you had asked 50 people what edge means, you get 50 different answers, which is a little scary. So what that means is that a lot of us have been kind of deluged with things that have to deal with the definition of edge computing. But there's some real challenges here that we have to consider in extending services, whether they're cloud services or even just capabilities to the edge. Now, edge computing really means, the definition of edge computing, and definitely from the AWS perspective, it means extending cloud services to the operator, to the edge, to the person that actually could use that data to make a decision, whether it's situational awareness, whether it's better healthcare, whether it's predictive maintenance. All of those things start with data, the operator, the creator of that data, and then bringing those capabilities closer to that operator, closer to that data source. So there is basically three laws that are really important and things to consider as we start that discussion and that continuum from the cloud to the edge. And it's the law of physics. How much compute do I need at the edge? How much storage do I need? What does that profile need to look like from a size, weight, and power perspective? The physical characteristics of putting a device like a Snowball Edge at 49 pounds are very different than putting it on a drone, as an example. So this is the reality of the state of edge from the size, weight, and power perspective. The other piece of it is economics, and this really starts with data. So the cost of managing data, there's a substantive cost to managing data, and the edge is not outside of that. So if you're moving data to the edge, and if you have your mission requirements at the edge, mean that you need to move data, or the data that's created at the edge, move data into the cloud, those are all considerations that need to be taken into play. And really, the overall aspect of edge computing technology, is to gain benefit to be able to build once and deploy in many places instead of having to introduce multiple systems, multiple levels of training, multiple things that need to be touched and leveraged instead of one common system, one experience from an operational and cost perspective. And then finally, the law of the land. So here, compliance, just because we're providing cloud services to the edge, doesn't mean the compliance goes out the window. As a matter of fact, it's even more focused on that because the edge, as a creator of data, creator of those, creator of the data that's needed for the services to be leveraged, operate in all ways. It operates in unclassed environments in the case of military, up through secret and top secret environments, or in cases where data needs to be ingested and leveraged locally for some critical mission that may have to do with the operation of an oil rig. Or anything that has to do, or in the case of a disaster, anything that has to do with personal information or anything that has to be leveraged to be able to capture that data and then leverage it for the operator to be able to exercise. So these are really the considerations of the modern edge discussion. So if I could lay this out, I'd lay it out kind of from the way that AWS thinks about this is the edge to cloud continuum. And if you look at this slide, you see that from the cloud and then all the way out is a set of use cases along the way. Whether it's delivering and extending cloud in the edge to an edge set of services in metro centers, maybe in on-premise locations where you need some local compute and local storage capabilities, but you also have some data that can't leave the building or can't leave the facility, the data center, let alone be set off to the cloud somewhere. Things like tactical edge, some of the areas that we're going to be focused on today are really around that tactical and rugged edge space. 5G. So again, you can hear the topic around 5G and edge computing, IoT. These are all combinations of things now that have to do with extending cloud services to the data creator, to the operator, to decrease the amount of latency, increase the amount of compute power, increase the level of services that they can leverage so that they can accomplish their mission faster. And then finally, down to microcontrollers and IoT devices. We were just talking about before we came up onto the stage here, the edge technology space is evolving very rapidly. It wasn't that long ago that we were just kind of conceptualizing moving the cloud to a location outside the data center. Well, that's what AWS is delivering. Now the conversation is even beyond that. It's all about size, weight, and power, and now coming into other scenarios even beyond that, down to the controller level, microcontroller level. That very prevalent in today's IoT sensor development. So if you look at this and probably think about the use cases that you're working or that you're working with your customers, there's probably the use case fits up here in terms of what edge means to you or to your customers. So from an AWS perspective, our approach is really from the cloud out. You know AWS from the 200 some services that are available today in the cloud and available to you to leverage. But this conversation is now about how do we extend those services, bring cloud services closer to the user, closer to the organization, so that we can address those needs for data residency, low latency requirements, and data sovereignty. So instead of having to today's organizational model is distributed information and distributed knowledge, distributed power. So how do we then bring those cloud services closer to that operator, closer to that action taker? The first stop is with AWS Outposts. And by the way, the things that we're talking about here today, you can stop by downstairs in our booth and see the Outposts, the Outpost rack, the 42U rack, and the 2U and 1U server there. So you start to see what that extension of the AWS Availability Zone data center looks like from a hardware instantiation. So Outpost is the first stop, customer premise. This is where we stop and we deliver those services into that local data center to address low latency, data residency, data sovereignty requirements and a subset of AWS services. You're basically capacity extending the AWS cloud into your data center. This rugged edge piece that I mentioned earlier is where the conversation around the Snow family and Snowball Edge are. And in this space, as we're going to see here in just a few moments, in defining what edge services look like in a cloud instantiation, you also have to make that instantiation fit into the environment. So the AWS Snowball was introduced about 6 years ago, and we listen to our customers here at AWS, and we always work backwards. We don't develop a bunch of stuff and push it to the market. The Snowball was developed as a data transfer device to help customers move data into their AWS storage environment. Well, today, again, listening to our requirements, that was the dawning of the AWS Snowball Edge, because we listened to our customers and they said, we also want compute power on this device so that we can do both, data movement and edge compute at the same time. So this rugged edge space, it is rugged, it is determined by size, weight, and power, but also packaging. So the best example of that is the Snowball Edge and the Snow Cone. Again, definitely stop by our booth if you haven't already, so you can see these devices and have a much deeper conversation. So today we are going to be focusing on that tactical and rugged edge space with the Snowball Edge. So I mentioned just a couple of things as it pertains to, now that we're moving down from really talking about what edge is to the rugged edge, here things are different. The profile's different. The form factor's different. Maybe we need those edge services in a device that starts as a sensor but ends as a cloud device. So here at AWS, we're looking continually at that size, weight, and power, that form factor piece, because it's important. Listening to customers, the reality is that the need for extending cloud services is expanding outside of the data center for sure, and it's expanding to smaller packages, smaller instantiations, and it's really to gain that edge value of bringing that data closer to the action taker, bringing cloud services, things like analytics, things like IoT aggregation, things like creating Kubernetes environments, basically compute and storage capacity at the edge. And in the case of the rugged edge, in military and other applications, it operates completely disconnected, no connection at all to the AWS environment. So these are really some of the primary drivers that are behind this broader discussion around edge and tactical edge in this space. So on the left, you see as the industry drivers are focused on really kind of laying the groundwork for edge computing, really our approach, AWS's approach, is to always work backwards from our customers and address these needs so that, again, in the case of the Snowball Edge, it's instantiated so that it addresses these primary functions. And then, in addition to that, we provide additional services. There's 11 services in the Snowball Edge device. It's not by accident, it's by purpose. So those services are what we heard from our customers and are delivering today consistently across the board. And also from a security perspective, number one, always, these days, whether it's in your enterprise environment, data center, cloud environment, but also in the edge, security is key. So as you heard today, but here also in this hybrid and edge discussion, security is paramount. So our devices, our services, all are AES 256 encryption for data in rest and data in movement, data in transit as well. So these are really important aspects of kind of shaping out how the AWS approach aligns to the industry. So I can break this down into three primary areas. You heard me mention it earlier in terms of kind of the primary reasons why edge is interesting. Latency is the need for low latency performance for applications that require a lot of data transfer, a little bit of data transfer, but are basically low latency performance. So bringing the cloud closer to the user is the way to basically instantiate that. So we don't have to deal with sending data back and forth, propagation delay, network delay, all those things. Bring that cloud closer to the customer. And in the case of the Snowball Edge, where the AWS data availability zone, that control plane in the cloud is actually present in the device. So you have local services here, 11 local services delivered in that control plane on the device. And then the final piece is here, as I said, looking at the cost model and using services for what you need. Whether it's interesting when you have the discussion about what services are available when and how to use them compared to what people are used to building in the region. Edge services, the requirement for edge services are different. Some people need them for a short amount of time. Other people need them for years. Other people want to be able to leverage edge services for longer than that, maybe forever. So the reality is that the service has to evolve, and the approach here has to evolve in terms of making sure that the ROI is constant, the ROI is there in terms of the leverage of those services, even at the edge. So the AWS Snow family use cases I mentioned two, edge computing and data transfer or data movement. And basically it's instantiated in the AWS Snowball Edge and the Snow Cone. A Snow Cone isn't here. It's the smaller cousin, about 4.5 pounds, size of a Kleenex box. Here it's a matter of capacity. Size, weight, and power and capacity is the difference. But it's the same set of use cases. Edge computing and data transfer, data movement. And I mentioned these can be deployed in connected or disconnected environments, depending upon what your needs are. And then also, it really isn't it taking a step towards advancing your analytics objectives. Because the services that are available here at the edge from the AWS perspective are very focused at consistent services with the region, consistent experience. So from a machine learning and AI perspective, building that model in the region with something like SageMaker and then deploying it in many locations on Snow devices is a very credible, very powerful way, very cost-effective way to have those models deployed and out running in remote locations and only have to touch that once, right, or a very minimal amount of times. So the value propositions here, as you see them, so as I've talked through a lot of these, the key things, a couple of things I want you to walk away with here, and especially as I transition the conversation with Quentin, is that, and we're seeing this time and time again, where customers and partners are really coming around to developing applications that leverage the power of what they bring to the table. So if your objective is edge analytics, then what's important is what that edge device is designed to provide. What services, what cloud services, what consistency with the region experience is there. So from an AWS perspective, as you heard me say, that is very important to us to make sure that you don't have to train multiple teams, multiple people on different devices across your edge to cloud continuum. The AWS Snowball Edge, as I said, 11 services. This is the 11 services, and it covers a majority of the edge portfolio, if you will, of popular services. But these are also the voice of our customers. Compute, storage, EKS, Kubernetes environments, SageMaker Edge, identity access management so that you have all the security of that environment. So it's really important to look at this from a holistic perspective as you're considering edge solutions and edge devices and extending those cloud services to you. From a defense perspective, these systems are designed, purpose-built for austere environments. So as the slide shows, they are designed to operate in very high, very low temperature ranges, dust, shock, standard compliance. They're also tamper-proof. We get a lot of questions about, hey, if I have one of these in the field, I want to change a drive or I want to add something to it. No, it's sealed. It shows up from AWS just like this. The little e-ink display in the top updates with the shipping information once it's unlocked. When you're done with it, unlock it. It ships right back to the region that you ordered it from. It's real easy to order a Snow device. You order it the same way you order any AWS service via the console. You just select what region and what type of device you want. So in defense operations, it's particularly interesting because now we're starting to address some of those extreme tactical, not only size, weight, and power, but some of the environmental characteristics of the defense environment. So with that, I'd like to hand it over to Quentin.
Oh, you're literally handing it over. Thank you.
I'm literally handing it over.
Thank you, David. That's great. We are, of course, huge fans of the Snowball and the Snow line of devices. As he mentioned, I'm Quentin. You can call me Q. I lead our space and defense business here at Hypergiant. Today, I'm going to walk through a few things, really diving into some of the unique challenges at the tactical edge. And I'm really going to focus on two types of edges. We'll see the operational edge, so something like an operations center. I talked about NORAD, NORTHCOM, guys who are in a SCIF running a secure environment who are at an edge, quote unquote, because they can't necessarily talk to a public cloud. So that type of edge. And then the kind of the rugged tactical edge that David was talking about, deployed out on a battlefield or deployed somewhere where your comms are contested, maybe you don't have great bandwidth, like that edge, when you think of edge out in the desert somewhere, that's the second kind of edge that I'll talk about. I'm really driving home this idea of decisions, right? So we are an AI company, sure, but AI, if it's locked in research papers or science experiments that's not delivering decision-making value, to me is just a fun little toy. We are trying to drive decision-making. So I'm going to talk about a common operating picture and the challenges of deploying a common operating picture in those environments where decisions are being made. And that's actually kind of how we've backed into requiring something like a Snowball, because this fantasy world of living in the cloud doesn't necessarily exist for all customers. You have to be able to deploy on something like this if you're going to make your decisions in the place where they matter. And we'll, of course, talk about AI and ML in these environments as well. So a little bit about us. We are Hypergiant. We're a small, scrappy team. We've been around for about 4 years, under 100 employees. We focus on design, so developing applications that, again, leverage AI. Again, a human is going to be in the loop making decisions for almost all of the use cases we're talking about. So you've got to bridge the gap between an infrastructure of machines and algorithms and that human decision maker. So we actually start there. What is the human going to look at? What are the buttons they're going to click? How are they going to make decisions? And then work backwards behind the scenes to deliver the models and the algorithms that are adding insights into the data. And of course, the infrastructure where those decisions could be made wherever that person is sitting. Our mission is, again, we are an AI company, but we are focused on empowering customers to make decisions at the speed of relevancy. And for those of you guys who are in the keynote, I really kind of hit on this. Speed of relevancy is critically important. If it takes you 20 minutes to make a decision, but your window of decision making is only a few seconds, you're kind of out of luck, right? And all of the data and all the amazing AI algorithms you may have behind the scenes are useless if they can't drive something to you in that decision window. So speed of relevancy is hugely important. We talk about the value of seconds, the value of minutes. For the Air Force who need to scramble jets, there is a price tag, quote unquote, not maybe US dollars, but there is a value that you can ascribe to every second that it takes for you to delay a decision, right? So anything I can do to tighten that decision window is inherently valuable to the decision makers. And not every decision maker has the same window. Some people have minutes to make decisions, some people have hours. But the idea is you who are making decisions out there in the operational front have a window of relevancy. And if the tools you have at your disposal can't deliver the decisions within that window, they're useless. So I live and die by my analogies and metaphors. They are, I would say, most of them horrible, but I'm going to throw one out here for you, and hopefully this resonates. But I want everyone to imagine, again, for those of you guys who are too young, you will definitely have to imagine. But let's say you're in 1992, it's 1992, and you're driving to a wedding in the middle of Los Angeles, right? 1992. So all you Facebook, mobile phone, forget that, right? This is 1992. The wedding is 2 hours away, and let's say it's at a place that you've never been to before. So you're going to have to rely on some tools to get you there. You've not made this drive before. Again, this is 1992. This is going to be an important concept. You're halfway there, you're running late. You're hungry, the kids in the back seat are hungry, right? There is a good chance you're going to miss the wedding if you don't make the right decisions, okay? What are your tools? Again, this is 1992, right? So you've got like Rand McNally like scrawled across your lap. You've got like a police scanner maybe on your dash trying to figure out where the speed traps are. You're running late, right? You got to get there in a hurry. Maybe you have the radio on. You're trying to hit that sweet spot of between songs and advertisements to get that one traffic update every like 15 minutes. You have weather from last night's evening news that you wrote down on a napkin. Your uncle scrawled some notes on how to get there. And then you find out that the road that you need to go on is actually in a new subdivision that doesn't actually exist on the paper map, right? Again, for those of you guys who are too young, you didn't have to deal with this, but this was a real problem that we had to deal with in 1992, getting to a place with some outdated tools. Okay, so let me bring you back into the modern era. It's 2022. You're driving to the same wedding. We have tools that guide you there in a single place. You pull out your phone, and no one actually thinks about trip planning anymore. You just say, I'll figure it out when I turn the engine on. My application tells me where the speed traps are. They tell me how long it's going to get there. They reroute me if traffic is going to be a problem. I don't actually care about the weather because the weather is factored into all the decision making that's presented to me anyway. If I'm hungry, if the kids are yelling and I need to stop for a restroom, that information is there as well, even if I didn't plan it beforehand, right? So this, like everyone has a paper maps problem, as I call it, right? We are trying to solve paper maps problems for our operators. How do I get something like this into the hands of people who are making decisions that are maybe more critical than just getting to a wedding? I guess that depends on which wedding you're getting to, right? And of course, we're really at this stage right here, right? Where you just sit behind the wheel and you just tell your assistant, get me to this wedding, I need to be there by noon, okay? And the key point here is that there is a ton of data, there's a ton of devices maybe at your disposal, there's artificial intelligence, there's machine learning, there's algorithms. You do not care about any of that. None of that's important to you. The only thing that's important to you is getting to the wedding and getting there on time, right? For this individual, their speed of relevancy or their window of relevancy is 2 hours. They got to get there before noon. Okay? So we could talk about the intricacies and the science fair projects of AI research papers all you want, but if you're not delivering a solution that gets someone to that wedding in 2 hours, you're not delivering value. Okay, so the right tools, the right environment allow you to contextualize and make decisions at the speed of relevancy. So now, and again, I'm bringing kind of a little bit of the story that I showed at the keynote here, but let's now, I don't want to go back in time. This is right now. This is this year or last year for a government customer. So let's say you're monitoring air traffic over Washington, D.C. Right now, your attention is divided across 7 to 10 different screens. You're having to keep track of weather, police scanners, maps, radar tracks, military radar, publicly available information. They literally got FlightAware up. You're watching the local news. Again, situation not really too dissimilar from trying to navigate to a wedding, right? All of a sudden, a red dot shows up on your screen, okay? It appears in your AOR, your area of responsibility. What do you do? What are your tools? Again, this is 2022. Well, unfortunately, you do something very similar to this. I kid you not, and this is actually true for many customers. So many customers still today in 2022 have a paper maps problem, okay? Air defense operators are still stuck in this, I got to merge data from 7 to 10 systems. Because again, it's not just 7 to 10 separate screens, it's 7 to 10 separate systems all deployed in their air-gapped environment. They aren't talking to each other, right? So I've literally got to join them with a piece of paper. I've got to decide what am I looking at, what's important, what are the courses of action I need to take, and I either go to a piece of paper or a whiteboard, sketch out the possible decisions, and then make the phone call to scramble jets, shoot something down, go acquire some more information. And all of this takes a tremendous amount of time. Now, of course, you can imagine if the human is having a hard time stitching the data together, there is no way that there's an ML algorithm that's going to be able to read those screens and come up with decision. Okay? So again, we are trying to solve these paper maps problems for these customers. And of course, what happens when you are able to utilize the tools, some of them very advanced? What if you aren't able to utilize those tools to be able to make a decision in your frame of window? Then you act out of abundance of caution, but you get stuff like this that appears in the news, right? This is not pointing the finger at anyone, right? This is pointing the finger at the tech community, right? We're not equipping the people, decision makers, with the right tools to make those decisions in their frame of relevancy or at the speed of relevancy. Okay, so this is a very, very hard problem, and it's important to dig into why it's hard. Data fusion at the tactical edge is very complex. Again, the edge we're talking about in the operational use case is that siloed, air-gapped, maybe it's a SCIF, there's a room where software rarely comes in and data rarely comes out, right? So being able to fuse stuff together is incredibly challenging. Tools do exist to solve this problem. Our company is definitely building some of these tools. A lot of these tools only exist in the cloud. Or some of these tools only exist in very manicured edges. So, I think of space operations, for example. There are a lot of really capable tools that are deployed into very specific operation centers. Those tools never live outside of that center. Maintaining that is a nightmare. And of course, integrating that with other operation centers is just a non-starter. Interoperability between these systems doesn't exist. And this fourth point is probably the key, and that is software development cycles at the edge do not, in most cases, incorporate the modern advances that cloud technology has been able to leverage for years now. And when we say cloud native, we're really talking about CI/CD, Kubernetes, containerization, like tightening that feedback loop so if I see an issue with software or if I have a new feature, I can deploy it quickly and get in front of my users. When we talk about the paper maps problem, remember, let's say you're driving to a wedding and that subdivision doesn't exist or the street's not there. What are your recourses? Well, you could try and get close enough and then figure out, oh yeah, it's clearly this subdivision. Or maybe you drive to Borders. Yeah, this is 1992. So you drive to Borders and you go find like the updated version of Rand McNally street maps for Los Angeles and hope that they have the new street. So the lead times there are like maybe a year. The sad thing is, and this is kind of depressing, Rand McNally may be deploying updates to their paper maps faster than we can deploy software updates to the edges in some cases, today in 2022. That's crazy. In some cases, there's literally maps that we're trying to replace the map tiles out on the edge devices, right? Because, again, there are literally missing streets. And I think we've all seen this with map applications. It takes a while for new streets to show up on the maps. But for these edges, these air-gapped edges, getting new software out to them is incredibly hard, and it takes an incredibly long time. So that's a problem. And of course, just as hard as it is to get software into the air gap, it's almost impossible to get data out. So if you are an ML company, machine learning, right? Machine learning lives on data. That data is the fuel of machine learning. If you can't get the data out of the edge, then you can't do anything with it unless you deploy ML into that facility. But of course, we've already said getting ML or getting any software into that facility is already challenging. I don't know the statistics, maybe you know this, David, but I'm seeing it several times that the vast majority of data actually never makes it to the cloud. It's all stuck on the edge. Right. And so if you aspire to do something interesting with the data, to inject insights via AI and ML, you have got to articulate it to the edge. If you're waiting for the data to come to the cloud to be able to do something interesting with it, you're not going to hit that window of relevancy.
And even to your point, the expectation is that going forward, the vast majority of data will now be created at the edge.
That's correct.
So both issues, right? It's a data management issue that affects the creation, the management, and then where the data is present.
Yeah, and there are combinations of nuanced problems, like if you're operating multiple different edges and they're all very similar, but they're all collecting data and that data never leaves the individual edges, well, how do you leverage the benefits of one edge getting smarter by collecting data and retraining algorithms out there? How do you use that advances at that edge to kind of hydrate or kind of spread forth those benefits to the rest of your edges? Kind of the modern electric car problem. These electric cars that are being developed that are incredibly intelligent. They're intelligent because they're leveraging the insights of individual edges flowing back to a central place. And a lot of times that isn't the data coming back. That is something else. Federated learning or a retrained model that is then being rehydrated out to those edges. So it's a tricky problem you've got to solve. So I'm going to talk through, again, our common operating picture because this is, again, key. The whole point of what we're trying to drive here is decision making. What we're developing is a common operating picture. We're trying to fuse data from multiple sources, get that into an integrated view, and then leverage machine learning to drive that decision making process. It has to be supported in the cloud, in cloud native environments, but again, it also has to be supported on something like a Snowball. I will say the number one thing that we love about the Snowball is that it supports EKS, right? Because everything we do is containerized and it lives on top of a Kubernetes surface. So for those of you guys looking at a Snowball and thinking this is just a big USB stick, It can do that, and I've heard that pitch, oh, Snowball is just a big USB stick, but it also runs Kubernetes, and there's a GPU in here, right? So the idea is if I can deploy a containerized application and harness the power of a GPU on this is going to be much closer to my decision-making process than something in the cloud. That is a critical aspect of the Snowball, and we just absolutely love it. And of course, saying that Kubernetes is on here, everyone should be thinking, oh, Kubernetes is on here. We can deploy anything I can deploy onto Kubernetes onto this box, right? And that is one of the key differentiators in my mind to give the AWS pitch here. This is not just another computer, right? When I open this up and pull up the console, it looks and feels like an AWS console. So, and it's connected to my same region, so everything just works. Just to run through a few screens here, here's an example of something we have on commercial cloud. If I'm on the edge, and this is actually running on commercial cloud, but it's also running on a Snowball. I think this screen grab was something we actually took from a deployed on a Snowball instance. So this is kind of a regional view. I am someone who's tracking assets, so my green and blue dots here, and I maybe need to keep track of weather. Maybe I even have local Doppler in my local network, so I can keep track of local weather patterns. I don't necessarily need to be connected to the cloud. My map tiles, I can pre-install map tiles on my Snowball. This is actually one of the crazy and most frustrating things about cloud and some edge-based map technology. If I am running ops in New Orleans, for example, I shouldn't have to rely on downloading map tiles from Hawaii, right? But we have a lot of cases, the development workflows, where I've got to make sure that I've got global coverage of map tiles to be able to deploy that to an edge place. If I'm doing operations in New Orleans, I really only care about this. Like, that's all I care about. I can stand to have limited visibility elsewhere. I just care about this region right now because this is where my decisions are being made. Zooming out, and I like to talk about satellites, satellite operations sometimes because for those of you guys who don't know, we only gather information from satellite location maybe once a day, maybe once a week. So perfect use case for Snowball. I can populate the Snowball with satellite information for all satellites on a Sunday, ship it out to my operation region, and then I simply use physics-based propagation to figure out where those satellites are going to be on any given day after the fact. Now, there's an error for that propagation, but it's as good as it's going to be in the cloud. I do not need connectivity to the cloud to do space operations in some regards. So again, use case of taking a Snowball, deploying it out to an operations center. And then zooming in, and we'll have another example of zooming farther in. So again, it's not just understanding what's going on. It's not just understanding the information at the edge. It's also being able to make and synthesize decisions in a quick manner. And so this is where ML is really important. ML at the edge is what's going to tell me what's important and what's not. Now, I'm still a human. I'm still making decisions. What should I go after? If I'm NORAD, I'm making decisions to intercept. I'm making decisions to scramble jets. I'm making decisions to shoot things down. Those are decisions that are going to have a human in the loop. But I still need machine learning algorithms to tell me, of these 500,000 data points, what are the most important things for you to look at? And of the ones that are most important, here's your options. You'd have no jets to scramble. There's no fuel at that airbase, or there's literally a hurricane. So don't even consider that. Don't put that on the whiteboard, right? In some regards, it's deterministic, very simple algorithms. In some regards, they're very complex. But the idea is, if you're in an air-gapped operations center, or if you're doing air defense someplace where network is denied, those ML algorithms need to be running on a box in your room. Otherwise, you're not going to have access to it. And again, if the ML algorithms are not running on the box in the room, then you revert back to paper map in your lap, or a whiteboard where you're doing expo math to try and figure out what are my best courses of action. I love these pictures. Again, these are the problems we're trying to solve. For our customers, we want to equip them with the right tools in the right environment. Again, to go back to the metaphor or the analogy of going to a wedding, nowadays the tool you're using is in your pocket, right? That's what we want to do. We want to equip our customers with the right tools that they need to solve their jobs. And it would be great if we can get here as well, right? You just want to sit back, drink your coffee and just say, Alexa, just take care of airspace monitoring over DC, and let me know when something goes wrong. So the last kind of use case I want to talk about is what we're doing for the Army. So the Army's got a new program, Robotic Combat Vehicle, RCV. This was really one of a line of new data-rich vehicles. This is an interesting concept, right? Which is, I want to go send a vehicle that is sensor heavy. It's collecting data from the environment. It's collecting data from the subsystems on the vehicle itself, things like tire pressure or strength of materials or oil temperature, engine temperature. It's monitoring things from the weapon system as well. Do I still have ammunition? Are things running hot, et cetera, right? But there's just tons and tons of data on the vehicle. And we, of course, want to make decisions leveraging that data, right? When should I stop shooting? When should I stop moving? When is something about to break? When is something getting too hot? When do I need to go airdrop a repair kit out here to go fix a tire, right? So this is really a new line of vehicles. Old line of vehicles were collecting some of this data. In a lot of cases, that data never left the vehicle. It was literally on a hard drive that never got bolted. And the only way to actually get the data off that vehicle was to actually unbolt the hard drive. So the vast majority of cases, just like deleted. So this is a really interesting use case. And I'm going to go to the next slide real quick to just talk about these echelons of edges, right? At the far edge, you have the vehicle operating, collecting data from the environment, collecting data from its own subsystems, and collecting and sending that data back to higher echelons. At the near edge, so this is at a company level, to use some Army terms, at a company level or maybe at the motor pool, where you've got someone literally with a snowball collecting data opportunistically, and doing things like trying to assess supply chain situations, maintenance situations, trying to get ahead of breakages, et cetera, and remediating when there is a break. And then, of course, at the brigade or battalion or Army level, you have the cloud. Data is going to rarely end up in the cloud. Or if it does, it's going to show up there months later. Data also may not necessarily make it to that near edge in real time. If I have a robotic combat vehicle, I can't necessarily turn on a radio. Turning on a radio is actually broadcasting your location, right? So in between these circles, you've got network challenges, contested networks, denied networks, maybe selectively turned off networks. So this idea that the further to the right I go, that's where decisions are being made. In some cases, the RCV, the robotic combat vehicle, is actually making decisions itself, right? But for the most part, those decisions, those supply chain decisions, when am I going to do condition-based maintenance, that's being done on this guy right here in a motor pool somewhere forward deployed. And then, of course, and I mentioned this in the keynote, sometimes the edge comes to you. It's not just in a skiff in Colorado Springs. It's not just in a battlefield in a desert somewhere on the other side of the world. Sometimes power goes down and you have to make decisions in an edge that is now someplace that you thought was a dense cellular network. I love seeing that Jeep upstairs with the snowballs in the back. Natural disaster, response, that's a wonderful use case for snowball, and I love that there's snowballs on the back of it because I don't even need to talk about it. You can go upstairs and see it, right? But the idea that it's not just a challenge for military, it's not just a challenge for air-gapped space operations. It can be a challenge for anyone when the internet goes down. Okay? And again, tying this all back, it is all about this decisions at the speed of relevancy. There is a vast network of sensors out there. There is a ton of really capable ML and AI at your disposal. But if you can't leverage those and deploy them to the right environments to make decisions, then you're not driving value. So with that, I'll stop. I hope we've thrown enough out there to spark some good questions. And at this point, I think we're gonna do some Q&A.
Well, thank you very much, Quentin.
Yep.
That was really, really great. And so with that, we'll open it up for any questions, any comments. So we'll wait for a mic here. We have a mic right there.
When you give the example of you called it an electric vehicle, but I think you were talking about an autonomous vehicle.
Yes.
I
was thinking Tesla, but then I was like, I don't want to say
Yeah.
anyone else's brand name in here. So
You said something about federated learning. Can you give some details? What does that mean? What are the details? What does that mean?
Yeah, so when we talk about traditional machine learning in the cloud, it's collect all the data in one spot so that I can have a single training pipeline that literally takes a model and retrains it against all the data kind of co-located. In some cases, you can't get the data co-located. The data, as we talked about, only exists at the disparate edges. So how do you train a single model if that single model doesn't have access to all the data at the same time? So federated learning is kind of this broad term talking about how do we go about training that model kind of at individual edges. How do you go about like training data against different data sources not co-located, or maybe taking a model and hopping it across the different edges so it's trained here, and then the model comes back, so those maybe neural network weights come back to the cloud, but not the data itself. So you deploy it out to an edge, gets trained there, pulled back, then deployed to another edge and gets trained. And every time it goes to a new edge, it learns something about that edge. I'm not an employee of an autonomous car company, but I don't believe that many autonomous cars are doing true federated learning. They're still doing pull all the data back to the cloud. So that's probably not a great example of federated learning, because that's still kind of centralized co-located learning. But yeah, federated learning is, I need to do my training out on the edge, and then I need to take the results of that training and then send it out to my other edges and then retrain them as well. And every time I do that, the individual edges can still benefit from a collective intelligence.
Yeah, and I think that's also a great example, Q, of the ingestion of data in that type of environment. So the sensor, the creation, the actual capture of the video, capture of the imagery, capture of the environment, whatever that sensor is designed to do, but also the log data that's necessary behind the scenes to be able to provide insight in terms of the operation of that data, its ability to collect, and then the levels of analytics. I guess that's my point. There's now levels of analytics that are necessary at the edge. One may be based on the training data and the mission at hand, and another may be just from an overall maintenance perspective, the health of the sensors, the health of the environment, the ability even to collect and store more data at the edge.
Yeah, and there's a really interesting use case when we talk about conditions-based maintenance, or like the health of the vehicle. From a federated learning point of view, if I ship one of these things out to a motor pool and I'm learning about the behavior of vehicles, I may be able to do some advanced anomaly detection based on the patterns I recognize from those, let's say, 20 vehicles in my area of responsibility. Then I can take this snowball, ship it back to kind of the battalion or brigade level. The snowball comes with it all of that data and those trained ML models, and then I can deploy those models out to new snowballs so that now my 200 vehicles or my 2,000 vehicle fleet can take advantage of the anomaly detection or the learned behavior statistics from that one small deployment. So that's kind of what we're talking about when we're talking about being able to leverage a collective intelligence. Absolutely.
Got it. Any other questions? Right here. We didn't mic. I think you're next. Is there another one there? Okay.
So, Michael, I have two questions. First, you drove home the point of how difficult it is to get data in and out of devices at the edge or at those operational centers at the edge. Could you maybe explain for us why that is so difficult, and maybe that's also an area that needs to be improved upon? And secondly, when you talk about these operation centers trying to, with that paper map problem, they have 7 streams of data and they're still using old techniques. How has your solution taken those 7 streams of data and integrated them into this single decision-making platform?
Yeah, so the first question is a tough one. Unfortunately, the answer is sometimes it's policy, sometimes it's security. You're literally not allowed to walk data out without filling out the right paperwork, and sometimes just the paperwork is a non-starter, right? So when we talk about space operations, for example, there are policy and security barriers which prevent you from exfiltrating data from those rooms. There are other cases where the infrastructure itself is simply not conducive to large-scale data collection. I know of some places where getting data out of tape drives involves someone sitting down in a basement with a cup of coffee and waiting 30 minutes to pull the last 2 days worth of data, right? That doesn't scale. What that leads to is the data just being stuck there. So some of these, and when we're talking about space operations, space sounds really next stage, but there are a lot of space operations that are stuck in the 90s technology-wise. Getting data out of those centers is just physically tough. And that's actually one of the reasons why it's Snowball. And I think the snowmobile was actually invented, was trying to come up with a physical way to move data from a building to the cloud. Like that's the genesis story of Snowmobile.
Absolutely, and to that point around moving data, as I mentioned, data transfer and data movement is very much a significant use case because of just that fact that there's so much data that's stuck at the edge, where that's so much data that's being created, but yet the requirement is to be able to leverage it so that more people up in the cloud and other organizations can leverage it. You kind of get focused on the speed of the network, the available bandwidth of the network, the connectivity, and say, well, if I have a petabyte of data that's now sitting at the edge, but yet I need to get it into the cloud, how effectively do you do it?
Yep.
So what we have customers that actually use Snowball devices, and we shuttle them to the customer. So they fill it, return it, fill it, return it, and fill it, return it, and then they get all of that moved, no impact to their data infrastructure, and then they get that data up into their storage environment so it can be better leveraged across other teams, data science teams and machine learning teams.
And to answer your second question, I mean, we're really the beneficiaries of an excellent customer in NORAD who has an appetite for modernization, right? So within the Air Force right now, there are efforts to do more joint, specifically joint all-domain command and control. So you have got to find a customer who has an appetite and says, I've got these 7 disparate systems and I want to pull that into a common place. I want to pull that into cloud. We could not do what we're doing if the customer did not have that appetite. I mean, it's just full stop.
Next question over here. Thank you, by the way. Oh, okay. Okay. You're next.
This sounds like a really fun problem to solve. Are you hiring?
This is coming from someone who is currently working for me. Yes, I mean, we will be continuously hiring. This is an incredibly hard problem that requires talent across a wide range of specialties, including data science, machine learning engineers, software engineers, people who can actually physically build stuff, container engineers, security engineers, absolutely.
Come see me after class.
Next question. Thank you for your patience.
Love it. So let me first say Gugum and Wahoo. So I come from the fires community, and what you're showing up there seems like an absolutely incredible customer-focused solution in every regard, and I could only dream of being the beneficiary of it. DoD tends to move at the speed of the FIDO, and I'm curious if you could talk about how you bring that innovation together with something that's so monolithic as the acquisitions and procurement process, and really try to focus on the customer and get it down to them. Thank you.
Well, gig 'em. But yeah, everything starts with sitting down at a desk with the people you're trying to serve, right? It's not a sexy answer, right? But if you're not doing that, if you're walking in the door with your biz dev team and you say to someone, "Here's a solution I have for you," right? You are missing the point. Everything that we do starts with us sitting down across the table or next to the people we're trying to serve. And everything ends there too, honestly, right? Everything you learn by sitting down and talking to your customer and understanding what are your pain points. If I'm going to actually join those 7 to 10 screens into one system, what does that actually look like to you? Is that even possible, right? It starts with that. And so that's really what we say is our secret sauce at Hypergiant. It's really driving that human-centric, design-led. And when I say design, it's not just the what looks good on the screen, but it's that design-led, how do I solve an actual problem for a customer? And then you back into things like Snowball. We didn't come in thinking, oh, I definitely need a Snowball. This gray, boring gray box is so cool, right? No, you come and you say, hey, look, you've got a problem. I've got this box of awesome.
Box of awesome.
Box of awesome. I've got this box of awesome that I think can solve your problem because it checks these issues that you have validated with me. And that is, for everyone here who works at a tech company, if you aren't sitting down with your customer and trying to understand their problems, and their problems are not necessarily technical as well. I mean, they could be acquisitions as well. How can I help you solve acquisition problems? I'm not an acquisitions expert. There are problems that I have not solved. It helps, again, to find the customer who has an appetite and has the ability to kind of turn the right acquisition knobs on the back end. But yeah, sit down at a table, for crying out loud, talk to your customer. Yeah.
Any other questions? Okay. So with that, I'd like to thank you for the Q&A, and just as a reminder, the value of coming to the summit is continue to build your cloud skills, and even after you leave the summit. So there's a lot of information that's provided that you should definitely take advantage of in the things we've talked about here today, but even broadly across the board as it pertains to AWS services. In the Skill Builder, it's 500 plus free digital courses, and then the AWS certifications that really shore that up and provide the foundation to that knowledge so that you can carry that forward into your organization. And then I do want to thank you, and then please complete the session survey. That's very important in terms of we use that data at AWS to be able to plan these events, come up with these topics, and really kind of focus on what your needs are. So please take the time to complete that survey. And on behalf of Q, thank you very much.
Thank you, David.
It's a pleasure.
Absolutely.
And thank you all for attending today.